Okay, welcome back. 5.1.3 Organic Reactions. So, in this subchapter, we'll cover about the organic reactions. Three methods of species usually encountered in organic reactions. So, we have three types of species. Free radical, covered in topik alkanes, unpaired radical substitution. Kita akan belajar kemudian. Electrophiles and nucleophiles, covered in topik electrophilic and nucleophilic additions and nucleophilic substitution. Covalent bond cleavage. Cleavage maksudnya putus. During reaction, the bonds in the reactants have to be broken prior to formation of new bond in the products. Breaking the chemical bonds is called fission. Bond fission consists of homolytic and heterolytic fission. So there are two types of bond breaking. Mechanistic arrows indicate breaking and forming of a bond. Half-headed arrow ni half-headed, dia ada satu kepala saja, setengah kepala. Full-headed, dua kepala. So yang half-headed ni is for single electron. Full-headed is for 2 electrons. Transfer of 2 electrons. So half-headed, single saja kepala dia, kamu buat arrow jadi macam ni. And this is for two-headed arrow. Okay. Okay. 4 types of organic reactions. So we covered 4 types of reactions nanti later on. Addition, elimination, substitution, and rearrangement. Okay. First one, free radical. Is a species, atoms, ions, or molecules that has an unpaired electron in its structure. It formed via a homolytic fission of a covalent bond. Homolytic maksudnya sama, dia akan pecah sama rata. Elektron dia akan dibahagi sama rata. So for this example, chlorine Cl2. Original dia Cl2. So dia akan pecah jadi Cl dot tambah dengan Cl dot. So masing-masing have 1 electron each. Okay, so dia akan pecah tengah-tengah. So another example, you have C2H6, your methane, no, ethane. So ethane tu dia pecah dekat sini. Dia buat fission dekat sini. So 1 electron will go to the ethane radical and another one to the hydrogen. So dia akan pecah jadi yang ini dan yang ini. Hydrogen radical dengan ethane radical. So this is another example of a free radical, NO2, which we covered in semester 1. Okay. Electrophile, E positive. Dia ada charge positif tetapi dia suka kepada elektron. So it called electrophile. It is a species, ion or molecule which accept electron pair from another substance to form a coordinate dative bond. Electrophiles are Lewis acid. Lewis acid sebab dia accept electron. Dia ialah positif dan dia akan terima elektron, dia suka elektron. So all positive ions, example hydronium, nitrogen oxide dengan hydrogen ion. Electron deficiency species, ni semua yang berbal tu. Carbocation ion, because it has a positive charge in its structure. Okay, nucleophile pula. Nucleophile ada Nu negative, so it's a negative charge. It is a species which donates a lone pair of electrons to another substance to form a coordinate bond. Nucleophiles are Lewis based. This is a definition of your Lewis base. Donates lone pair is a Lewis base. All negative ions, OH negative, Br negative, I negative. Neutral molecule with lone pairs of electrons. So water ada 2 lone pair, nitrogen pun ada. Nitrogen ada 1 lone pair. Ni nitrogen ni pun ada 1 lone pair dekat sini. Water ada 2 lone pair. Sini ada lone pair, sini ada lone pair. Nitrogen ada satu pair. Nitrogen ni pun ada satu pair dekat sini. So all the species can act as a nucleophile sebab dia ada kawan pair dekat sini yang membawa extra electron. Okay, molecule with electron-rich bond, double, triple, alkane, alkyne, benzene. Sebab triple bond, kita tekan triple bond, double bond. So this is full of electrons kat sini. So this bonding, double, triple bond can act as a nucleophile. Negative charge. Okay, homolytic fission. Two shared electrons of covalent bond are split equally. Sama rata elektron yang tadi. Okay, equally with one electron going to each atom. The resultant species are known as free radical, what we covered before. Okay, so A dengan B, masing-masing ada satu elektron being shared together. So in this reaction, bila dia mengalami homolytic fission, A akan bawa satu, B akan bawa satu. So this is a A radical and this is your B radical. So for example, for the chlorine just now, so we have a blue chlorine and red chlorine. Untuk nampak lebih jelas. So biru akan pergi ke chlorine yang kiri. The blue, the red electron goes to the chlorine on the right side. So both of them will become a chloride free radicals. Two free radicals kat sini. So for the ethane tadi, contoh ethane pun sama. So one goes to carbon kat sini, one goes to the bromine atom. So it will create an ethane free radical which has one extra electron kat situ, and the bromide free radical which has an extra electron kat situ. Heterolytic fission. So hetero tahu benda yang tak sama. So dia tak bahagi sama rata all the electrons. Both of the shared electrons of the covalent bond goes to one atom. The resultant species are known as ions. This is what we normally do lah. Contohnya HCl. So bila dia pecah dapat H plus dengan Cl negatif. Sebab Cl tu diambil dua-dua elektron daripada sharing electron tu. So both of the electrons being shared together is being transferred. Both of the electrons transferred ke Cl bottom. So this is a hydrogen ion. This is a chloride ion. So hydrogen ion kamu daripada satu elektron dah terus satu elektron kat situ. So it carries a positive charge, whereas for your chlorine it carries a negative charge because it has an extra electron kat situ. So the same for the next example. Br. Kat sini dia share kat Br. So Br dengan C ada shared electron kat situ. Ada dua shared electron. So when it transfer electrons, both of the electrons is being transferred to Br. So Br akan dapat charge negatif. C kat sini akan dapat charge positif. Okay, anything that have a positive charge from carbon is called a carbocation ion. Positif. Charge positif. So ni contohnya carbon ni akan menjadi charge positif. For this example, so the carbon will have both of the electrons. Both electrons is being transferred to carbon. So the carbon will have a negative charge, the hydrogen will have a positive charge kat situ. So anything carbon with a negative charge is called a carbanion, whereas for the hydrogen, it lack of electrons, so it will become a hydrogen ion. So, did you notice this arrow? The arrow ni ialah full headed arrow. Sebab dia carry dua charge kat sini. Dia transfer both of the charge pula. Electrons, sorry. It transferred both of the electrons here. So you will have a fully headed arrow. Okay. Ini pun fully headed arrow. So make sure arrow is betul. Okay. It goes to the reactions pula. So addition, electrophilic or nucleophilic reactions. This is the first organic reaction kat sini. So two reactants added together to form single product. Alkene jumpa dengan XY, example HCl. So dia akan buka the ikatan, the double bond, and will become a single bond later on. So this is what we call as electrophilic addition. Kenapa electrophilic addition? Kenapa bukan nucleophilic addition? There is a reason for it. So I will cover this reaction later on. Okay, ini untuk C double bond C. So sama juga C double bond O, which is your carbonyl. Okay. So this is a carbonyl. So carbonyl bila jumpa dengan nucleophilic, dia akan jadi nucleophilic addition. So nucleophilic akan masuk dekat sini, dia akan serang dekat sini. So nucleophilic akan attach pada C. O nanti dia akan ambil H nanti dekat situ. Nanti belajar reaction ni. So this is the first reaction, addition reaction. So the second one, elimination reaction. So elimination reaction, single reactant splits into two products. Dia eliminate benda tu. So daripada X, Y, dia buang, dia akan mendouble bond dekat sini. So bonding ni tak ada, bonding ni tak ada. So it become an alkene and XY dekat sini. So elimination reaction. Reaction saja. The fourth one is rearrangement. So we didn't cover that part in this topic. So practice. Kita dah discuss ni dah lancar. So I just give a brief answer to this practice question. So classify the following reactions: addition, substitution, or elimination. So you see, R dengan SH. So dia dah bertukar tempat. So this is a substitution, nucleophilic. Kenapa nucleophilic? Sebab ini charge dia ialah negatif. Bila charge dia negatif, dia ialah nucleophilic. So dia substitute lah kat situ. So the same goes here. You have a double bond here. Kalau tak nampak, buka dia punya structure, expand the structure. So it will become CH3. This will become CH3. Ni double bond. CH2. CH2. Okay, CH2. So dia masuk dengan HL. HCl pula HCl. So HCl will masuk dekat sini, H kat sini, double bond tu akan terbuka. Double bond terbuka, Cl akan masuk dekat sini. So this is a addition. Sebab kamu add in HCl dalam reaction. Okay, same goes here lah. Elimination reaction, and the fourth one is nucleophilic substitution with arrangement. Okay, checkpoint pun dah buat itu. So these are the answers. Just recap with your notes. Checkpoint question 1. Checkpoint question 2. Identify the following reaction as homolytic fission or heterolytic. So this is quite easy. So yang ni pecah sini, ada positif, ada negatif. So this is a hetero. So yang ni ada satu elektron kat sini, satu elektron. Ini akan tukar kat sini pula. So dia ialah homo. The third question. Classify the following reaction as addition, elimination, substitution, or rearrangement. So